looked at some of the key features of the graph of a quadratic equation. In this video, we're going to use those key features to help us make the graph and to also solve the quadratic equation. We'll talk a little bit what those solutions are. So first off, we want to look at some of the important features here. We know that the number in front of x squared is our a value, which happens to be a 1. The number in front of the x term is our b value, which happens to be a 3. And our c value is a -4. So I'm going to use those values to help me find important parts of the graph. The first important part that I want is the axis of symmetry. I want to know where halfway is, or the middle of my graph is. So that formula, in case you've forgotten it from the last video, is the opposite of the b over 2 times a. So opposite of 3 over 2 times 1 is going to be -3/2. So in my graph, and you'll have to bear with me because it always takes me a couple times to get halfway decent lines. This one's so-so. I want to make this fairly big because I kind of have an idea of what's going on. So my axis of symmetry is at -1.5. And again, I like to use the dash line because technically the axis of symmetry is not really part of our graph. It helps us make our entire graph. The actual graph is the U-shaped part, the parabola part. Now I need to know where the lowest point on the graph is. So I'm going to, the lowest point, and I know it's a low point because the graph opens up. Since a is positive, that tells me I'm going to have a minimum. In order to find that, I need to take the x value that I got from my axis of symmetry and plug it into the equation. So x squared will be -3/2 squared plus 3 times -3/2 minus 4. 9/4 minus 9/2 minus 4. 2 1/4, if this is easier, minus 4 1/2 minus 4, whoops, is going to equal -6 1/4. If you're not sure, you could always grab a calculator. 2 1/4 minus 4 1/2 minus 4, -6 1/4. So now I'm going to take that and I'm going to graph that point on my axis of symmetry here. So I know that the point is going to be -3/2, which is -1 1/2, -6 1/4. 2, 4, 6. We'll just use these going up and down as going by 2s. So -2, -4, -6, -8, -10. Along here I went by 1s. I think it's going to be helpful to see what happens here in a little bit if we go by 1s. Okay, now I know that I can find my y-intercept if I cover up this and cover up this. My y-intercept is going to be at -4. I think I mentioned in the earlier video that the y-intercept is always the c value. So the c value in this one is -4. So we'll make it right here, which is 1 1/2 units away from the axis of symmetry on the right. So 1 1/2 units away on the left is going to be another point for my parabola. Because we've got our idea of symmetry, we have to have our points be the same distance away. Okay, now I want to find some other points on my graph. And I'm going to usually try to plug in some easy points. I do need to get those circles off of there though. So I'm going to have to come back here and put 0, -4, and then the same distance away on the left. I was covering up my x's and I didn't want to do that. So let's see, another point that's going to be easy to try is if I plug a 1 in for the x squared. So I'm going to let x equal 1. 1 squared plus 3 times 1 minus 4 is going to give me a y value. And that's going to be 1 plus 3 minus 4. 4 minus 4 equals 0. So y equals 0 when x is 1. This actually happens to be a very important point in the solution process of this graph. When you solve a quadratic equation, you are trying to find out the values for x that cause the equation to equal 0, just like it says here. So when you're solving, you want to know what numbers for x make my equation equal 0. Well, we just found one. When we plugged x in, or 1 in for x, we found the answer that we got was 0. So that is one of our solutions right there. Now let's use symmetry to get the other one. This positive 1 is 1, 2.5 units away on the right. So if I go a half, 1, 2 more units away on the left, I can find my other axis, or my other solution, my other x-intercept. So your solutions are your x-intercepts. Even though we filled in that parabola, the most important points lie one here and one here. The solutions to this are at x equals 1 and x equals -4. When we did linear equations, there were many solutions to it. While the value of the equation that caused it to equal 0 there was going to be one place that it crossed the x-axis. In this case, because the graph has this U-shaped, it's going to cross the x-axis. If it crosses it, it's going to cross it 2 times, 1 time, or 0 times. In this example, it happened to cross it twice. An example of a graph that would cross it 1 time is if the maximum or minimum point happened to be right on the x-axis. So there's a graph that has one solution. Actually, it would be a repeated solution, the same solution 2 times. And the other possibility is if the graph looks something like this, and it never crosses the x-axis. That one has no real solutions. Okay, so that's solving a quadratic equation by looking at its graph, which we can also do on the graphing calculator, and we can take time in class, a lesson in class, to go through how to do that.